Hello everyone, and welcome to this live event dedicated to EcoPulse, the first distributed hybrid electric propulsion aircraft demonstrator developed jointly by three companies, three leaders of the aerospace industry, Laguerre, Safran, and Airbus. Today, we are here to celebrate its first flight campaign, which has been a great success and which is already leading the way towards the sustainability of aviation. We are in Tarbes, with some of the key ambassadors of those three companies that led this revolutionary project, with the support of CORAC, France's Civil Aviation Research Council, as well as the DGAC, French Civil Aviation Authority. Let me present to you those ambassadors. We have, from Laguerre, Pascal Laguerre, Chief Technology Officer, and Christophe, who is the head of aircraft design. Welcome, gentlemen. Now, next to you, we have Eric Dalbiez, who is the Senior Vice President of Strategy of the Safran Group, as well as its Chief Technology Officer. And next to you, Eric, Jean-Baptiste Manchette from Airbus, the Head of Propulsion of Tomorrow. We're going to hear about your stories, your insights around this incredible adventure. But there's not just you as guests today. We have the pleasure to welcome, in a few moments, one of the experimental test pilots who led that flight campaign and who will share with us his precious feedback. You are connected either on LinkedIn, on YouTube, or on the Jump Seat channel. Welcome all. We will have a dedicated Q&A session in a few moments, so please, you are most welcome to ask your questions on the chat, and we will take them later. So, for the past decades, the aerospace industry has achieved a prodigious challenge: make millions of people fly. But it's actually facing now an even more crucial challenge, probably the most crucial of its history, paving the way to decarbonization by 2050. Eric, can you enlighten us about the solutions which are within our reach to achieve that ambition of climate neutrality for air transport?
Yes, Caroline. In fact, first, the challenge itself, as you recall, is really thrilling because we are currently, all of us, experiencing the fourth revolution of aviation. First one was to make flight just technically feasible for a heavier than the air. Second revolution, flies safely. Third revolution, make the flight affordable, and now make the flight sustainable. So what is the sustainability agenda of the aviation? This agenda, and that's quite peculiar to our aviation industry, is completely shared by all stakeholders of the value chain of aviation, and even endorsed by professional association for air transport, or even the United Nations through the International Civil Aviation Organization. What does it consist of? The challenge is very easy to describe. Today we have a certain amount of emissions of CO2 attributed to aviation. If we do nothing but to replace obsolete aircraft with the latest, most advanced generation of aircraft in the coming decades, this amount will more than double. So just using the technologies of the past is not the key to achieve the challenge, because the challenge is not just to stay at par instead of doubling, it's decreasing this emission so that we can fly net zero as soon as 2050. So how to do it? This is a trajectory and the strategic agenda of the decarbonization of aviation with three main levers. The first one is trying to reduce as much as we can the fuel consumption of the fleet. Why? Because the fuel burn is directly related to the emissions of CO2. So the first lever consists in finding the ways and means through the technology to reduce the fuel burn, and thus moving towards what we call the ultra-efficient aircraft generations. Second lever is to optimize also air traffic management and operations on the ground to reduce the waste in fuel consumption that occur when you have to wait in flight because the airport is congested, for instance, or to operate on the ground in a more efficient manner rather than burning kerosene on the tarmac, for instance. And the third lever is to say, well, once we have found the ways and means to reduce as much as we can the fuel burn, Now let's consider to burn something else than the fossil kerosene we used to burn for decades. And it's the route towards alternative fuels, CO2 regenerative fuels, so fuels that by themselves will not emit as much as CO2 as the original fossil fuels. So ultra-efficient technology, air traffic management optimization and operation optimization, and alternative fuels. These are the true recipes for success.
Alternative fuels that we also know by the name of SAF, correct? So, with EcoPulse, you're exploring the wide range of possibilities of propulsion electrification. This is the one lever that we're talking about today. Jean-Baptiste, can you remind us, first of all, how hybrid propulsion works and why it is key to decarbonize aerospace?
So to come back to what was said by Eric just before, one of the first pillars is the technologies, and hybridization is really in this pillar, and this is where we are developing and the understanding of the hybridization and how it works at aircraft level. So basically, hybridization is the kind of recipe that we have between having an efficient thermal engine and using some electrical power in order to use it at various phases for the aircraft. So basically, the whole purpose of the exploration we are doing with EcoPulse is learning how we balance the sizing of this electrical power to make it the most efficient, to use it where it's well needed in order to reduce the overall fuel burn of the aircraft and therefore contribute to the reduction of the emissions.
Okay, so we were mentioning the fact that you have three leaders of the aviation industry. It's a unique partnership. How did this actually happen? What has been the genesis of this project? How did you make your interests align?
Oh, maybe I would answer for the equipment maker because my two colleagues are aircraft makers. For us, it's quite obvious. We are specialized at Safran in equipment, everything that relates to equipment on board, but not the aircraft themselves. So for sure. So what is interesting for us, when we have the idea of a technology, is we say, well, we will develop the component, improve the science of this system arrangement and so on, but after that, we need to fly it. We're not an aircraft maker. Is there an opportunity to build a project where we could partner with an aircraft manufacturer so that our system get a chance to be tested in real condition in flight? If so, this creates the case for Safran to partner with others. So that's, in a nutshell, a good reason for us to find the ways and means to build this kind of partnership, and especially the fact that we have the same roadmap, the same strategic agenda for decarbonization is also a good reason to find avenues for cooperation rather than competition.
So I'm looking to Diana because you're providing the aircraft. So how did you decide to work together on this specific project?
Yes, I will jump on what Eric just said. Actually, we have the same objective. We need to work together, and actually, we work together, and we are aligned, and we are in a specific committee which is called the CORAC, Conseil de l'orientation de la recherche de l'aviation civile, that gathers all the main industry of the aeronautic in order to align the technological roadmap. And during several CORAC sections, we have been speaking about hybridization, exactly what was saying Jean-Baptiste before. Well, what is the right level of electricity to use depending on the size of aircraft and whatsoever? And therefore came an idea, okay, let's die. We have an aircraft, it's cheaper to put in flight than an A320, I think. You agree with that? And we can make a flight test bench. Forget PowerPoint. Let's go to flight. Let's go to real life. And we said, we bring the TBL, Safran, you bring the bricks of your electrical roadmap, Airbus, you bring the battery, you bring the flight calculator, you bring the aerodynamic simulation, things what you know to do by heart, in details, and let's do it together. Because at the end of the day, it's a question of doing it together.
We actually have gathered some exclusive images of the aircraft in flight, and I think this would be the perfect opportunity for you, Christophe, to present us all the major transformations that Daguerre has integrated from Safran and Airbus. Can you come with me?
I will.
Okay, so let's have a look.
So, as I said before, we came on a table like with a demonstrator on the basis of the TBM. But if you take a look at that, it doesn't look like a TBM. A bit, but not exactly. We have added a lot of things on the TBM. First of all, of course, and you see it, we have 6 e-propeller electric motors with each propellers on the wing. Why is there 6? Actually, we tried to put as much complexity as we could on the aircraft, and there was not enough space to put 8. So that's exactly why we put 6. So 6 of them, electric motors. If you take a look on the side of the aircraft, you have an air intake and an exhaust here, which means inside the fuselage, we have an EAPU, it's an electric generator, which is inside the fuselage and which generates electricity to give power to the engine. If you take a look underneath the aircraft, you will see there a battery. It's a battery that has been given by Airbus and provide also electricity. So we have electricity in 2 ways.
What is the voltage?
800 volts. That's a lot. But we are not used to that.
It's
and
vertiginous.
Yes, I will come back to that, as a matter of fact. So yes, that's a perfect view. So here we have the battery. So we can use either the battery or the EPU in order to have electricity for the e-propeller here. We can use the 6 engines at a time, 6 motors at a time, 2 motors, 4 motors. We can use dissimilarly on the motors, which means more power on the right wing than on the left wing. We can do a lot of things like that. That's the beauty of such a configuration. And as you said, that's why I was coming back on the 800 volts. Usually, on aircraft, general aviation aircraft, we use 28 volts. On commercial aircraft, you will use alternate 115 volts, standard. What we are using here is 800 volts, and that's a complete different story. That's different physical phenomenon, and we had to deal with that during all the project.
Now, what about the cockpit?
Okay, of course, an aircraft at the end of the day is an aircraft. You need to put a pilot on it, and you will see the pilot afterwards. And it needs to have an interface, so we had to think on how do we define an interface for the pilot, even if he's a test pilot, to make him able to control those 6 motors plus the initial motor in the front. We stay with kerosene. And that's a specific HMI that we had to develop, human-machine interface that we had to develop. And if you take a look at the cockpit, you will see also here, you have a stick, a joystick. It means that the pilot is able to fly the aircraft just by using this joystick, which is just acting on the e-motors, which means by using plus or minus thrust, dissymmetrical thrust, you can fly the aircraft with roll or yaw, and that was one of the points we wanted to do through the project, and that goes through the calculator of a controller of Airbus, and with specific aerodynamic laws that has been done through the models of Airbus that we have done together, but based on the Airbus knowledge. So that's the same pitch and
Something
flight.
strikes me here. What is this red button for?
Yeah, the thing is, when you are in test flight, everything is about safety. And when you are putting so much technology on an aircraft, because, of course, just come back on a second. In EcoPulse, we have put so many bricks. It was first time most of those bricks were flying, and they were together in the same aircraft. So we had to take care, first of all, about safety. And the red button is what? It's a panic button. I will call it like that. Whatever happens wrong, you just push the button and it shuts down all the electrical system that has been installed from the initial aircraft. So the pilot comes back to, let's say, the initial aircraft or an aircraft which is close to the initial one. As Thibaut will explain later, I think we did it step by step, actually, in order to do that.
So it's also a Zen button, in a way, then.
Yeah. Yeah. And that's one of the points, actually, of the project. People see technology, people see the propellers, people see object you see, but at the end of the day, the process of demonstrating safety, which is the basis of the process to certify tomorrow, is key, is a key output of the project. It's something good to me to make something flying is good, but to be able later on to certify it, to justify safety for the authority and for people to step in the aircraft, as a matter of fact, is
it's
something...
number one priority.
Yes, it's still... It has been said by Eric on the different revolution. Second revolution was to be able to get safety, and definitely we will not come back on that. Aircraft in the future will be sustainable, but they will have to be safe and they will have to be certified. And we need to tackle that and not to forget that when we introduce new technology. 800 volt on an aircraft, having 800 volt cables near the fuel tank is something, for example, you need to take care of, and type of details we had to take care of during the project.
There's another thing that you wanted to highlight. It was the collective efforts from your teams. It's been a unique blend of skills, expertise, and test resources. And I think some of those team members are present here today.
Yes.
Oh, and I see that they've dressed for the occasion.
Thanks for the dressing. Okay, yes, the teams, very important. I just show you a picture there, and this is part of the teams. We have implied a lot of people in the team. So you had, of course, white collars, blue collars, people from the maintenance, people from manufacturing, managers, and so on and so on. And this is key. We have trained a full generation, and we say we, it's Daher, Safran, and Airbus, a full generation of those people for the future. So I will introduce a few of them. Didier, from Daher, taking care of the project. Pierre-Luc, Michael, from Pierre-Luc and Michael are from Safran. William from Airbus, Vincent from Safran, and Thibault, our test pilot from
He was
Daher.
dressed differently indeed.
Yes, he's a test pilot.
Yeah, I think his suit rings a bell.
Thibault, if you want to come.
Congratulations.
So,
And Thibault, yes, you stay with us.
Yes, I will like the mic to Thibault Zouf. You can explain in details what you felt.
Okay.
So Thibault, please come with me. I think we're all very curious to know your feedback about your flight experience. You're used to fly, let's say, classical TBM 900 aircrafts. So it must have been quite thrilling, very excited, but also very humbling to pilot an aircraft with so many new features. First of all, can you tell us which approach you chose in order to tame this new plane?
Okay, yes. So it was a very progressive approach, kind of build-up approach. So we used to perform 4 phases, 4 steps for that to open the complete envelope of the aircraft. So first of all, the first phase was to identify and to fly the legacy aircraft with a marker battery underneath and a representative CG and mass. So we have some equipment on board, and we went through this phase to identify the kind of legacy aircraft. The second stage of this flight test campaign was to add pair by pair the e-motors on the wings of the aircraft. So we did that first of all with the middle pair of the e-motors. I don't know if we can see that on the picture. So the middle ones, and then we added 2 additional e-motors, so the inner ones, and then at least the outboard engines, e-motors at the wingtips. And we opened the flight envelope like that. That was the second stage of the rocket. The third stage of the rocket was to electrify the complete aircraft. So we activated the battery and the auxiliary power unit. First of all, on the ground. So we did a large flight test campaign on the ground initially to be sure of the safety of the aircraft. and then we flew the aircraft with the complete system. So we electrified it. So we activated all the e-motors and all the systems. At the end, we flew the aircraft for the fourth phase. So we did a couple of points for Airbus mainly acoustic points, so inside and outside acoustic flight test campaign. We did some flights to assess the flight performances and handling qualities and flying qualities as well. So that was the main phases of the flight testing campaign.
I see what you mean by a step-by-step approach,
step-by-step.
Probably indispensable given the number of innovations which are embarked on the aircraft. Can you tell us how different it was to fly it compared to a classic aircraft?
Okay, so for that point, we did that step by step. So it was really interesting to fly through the fly-by-wire system, so controlling the yaw and roll or both through the flight computer. But we had also a lot of constraints, so speeds, thermal constraints. So it was very cool and very nice to fly that uncommon aircraft. That's pretty much it.
Okay, so sensations in the cockpit, pretty similar, but I guess how does it feel to be part of such an incredible adventure?
It was an honor to do that with all the teams, so from Laguerre, Safran, and Airbus. So it was a very good experience for me to fly this prototype.
Can you tell us how many hours you have accumulated on this aircraft?
I think we flew about 100 hours, more or less.
Not bad, huh?
Not bad.
Well, thank you very much, Thibaut, for this feedback.
Okay, thank you.
Now, it is time for the Q&A session. So we have gathered some questions from the different chats, and if you are now ready to answer authentically, sincerely to what they might have asked. Let's start with the first question. Do any of the partners see the need for a follow-on test program, either with this aircraft or with a larger one? Who wants to start?
I take it. Yes, of course, because after this long journey, as mentioned by my colleagues, we learn a lot. We are still analyzing our flight data. But we have still to continue the assessment of some technologies in order to assess their maturity. And so with Safran and the help of CORAC, we'll launch a new program called Tagine in order to continue to assess these hybrid electric technologies and to prepare the future aircraft in a dire perspective, because the idea behind this is, of course, to have an aircraft that really decarbonize, and so we will work on this more electric aircraft to prepare the future.
Yeah, and maybe to complement on Airbus side, we already have a strong partnership with Safran in order to test what means hybridization on large aircraft. So we are going to explore. There is a program in CFM with the RISE project, and we are working together with Safran. And our purpose is also to go in flight. And to go in flight is just fun. It's really great. I mean, for all the people working on it, you are glad to go there, but you learn so much, because we were speaking about alignment of roadmaps. But alignment can be on paper, but when you need to do a demonstrator, you just bring what you want, what you need at the time of the demonstrator. So this is just illustration of what means a demonstration, and the learnings is when you start to work together up to the time you go in flight and during the flight test campaign. Really very impressive learning there.
Actually, I was going to add this question, because I'm aware the consolidation of the results of the flight campaign are still ongoing, but are there some takeaways that you can already share with us for each of your companies?
Yeah. First, capitalizing on what Jean-Baptiste said, in fact, real conditions never lie. So that's the reason why we praise so much any opportunity to put our technology on the test bed, first on the ground, but as early as possible when it pays off in flight. In terms of feedback, technical feedback, especially from this test campaign. So for Safran, first, we had a clue about a technological bet we made about the way to cool these electric motors, the 6 electric motors, because you have alternatives to do so. Like a car engine, you can cool this with active cooling, with a circuit, with a cooling fluid and so on, and pumps and so on. That's not the bet we did. We wanted to be as simple as possible, because the simpler, the lighter the engine. So we took the bet to just cool this with the outer air of the flight, and that way, no active cooling system. So it was a bet. I was not sure it could fit the very demanding electrical condition of the operation of this electric motor, and actually it worked well. So that's good for this size of electric motor. That's promising for the future. And the second lesson that is learned for us, that is really invaluable, is the fact that we had the unique opportunity to put all our electrical components inside a system loop. And this is also the way to test this against real condition is really invaluable for us. So that's rich, especially for the next step for us, especially due to the fact that one of our big battles for the future, jointly with the aircraft manufacturers for commercial aviation, is to put hybridization inside the very big engines, big turbofans and so on. So the RISE program, demonstrator program you referred to, Jean-Baptiste, is actually a hybrid electric system. It's not just a gas turbine. So that's also paving the way for us, for the technologies, to secure the road to this demonstration.
I'm turning to, well, maybe if Airbus wants to
so actually we had 2 big learnings around that. One is around the aerodynamics and the flight controls. So clearly, exploring this field of experiment, using the electrical power to understand the behavior of the wing and how we could improve the lift, reduce the takeoff distance, use it in climb and in cruise. This was really the big learning we had. Behavior, aerodynamic behavior of a blown wing. This was very important for us. We did some wind tunnel tests in our facility, and we consolidated the models. And when we were speaking about ingredients, there are these things that we are going to reuse, of course, in the future. So quite important, very important. And the second big learnings we had is not only during the test campaign, but also preparing all around the battery. We know that inside for Airbus, the battery itself is an area where we need to understand how it works. It's going to be one of the key parts of the hybridization, and the way to master how to design, manufacture, and clear for flight is very important for us. And we are really proud inside Airbus to have done this kind of 800-volt battery, which is a first for us, and really glad to have contributed to this on the demonstrator.
And now if I turn to Daer, I know that you would like to embark this propulsion system on a future aircraft. What answers has the campaign given you?
As a matter of fact, those new configurations is a change of the perimeter between the aircraft manufacturer and the system provider. And we have defined for the experience of EcoPulse what is this new perimeter. So we are able internally in Daer to know where we have to work in order to be at the right level, to specify the right level of things to our supplier. That's the first output, which is very, very, very important. Second output is also about the process, certification process. We had to demonstrate safety to put this aircraft in flight. And that's demonstration of safety on a configuration which is unknown, which means there is nothing written on the papers of authorities on how to do it. So we had to define a process who is able to speak about the unknown, and at the end of the day have someone that signed, yes, we are safe. And that's really the basis of the future to certify an aircraft.
Yes, because I just want to complete. We are talking about aircraft, and you probably read in the newspaper that some vehicle, buses, cars, turn into fire due to batteries issues. So it's easy when you have a vehicle at the level of the Earth, an issue appears, you stop the vehicle and the passenger can get out very easily. In our aircraft, it's of course much more complicated. That's why we work a lot and we learn a lot on the certification process, because an aircraft, it's much more complicated than the other electric vehicle we are dealing with in our day-to-day life.
And this provides the perfect transition to our next question. Can you give some examples of unexpected issues on EcoPulse?
Okay, I'll take that one. So first of all, I have to say that each unexpected issues, which is delays, cost, burden, is a good news. That's exactly what we want to see in an R&D project. As I said before, EcoPulse has been designed to put as much complexity as we could on a single aircraft. 6 motors, very close together on the wing, 800 volts, with a cable in front of the wing tank, and so on and so on and so on. So yes, we got an issue. But that's exactly where we learn, because when you have an issue on which Daher did not see it, Safran did not see it, Airbus did not see it, it means that there is really something that you see only if you do a demonstrator. You don't see it on paper, you don't see it on PowerPoint. So, can I say one? Yes, we had to increase the level of protection on the cables, because at the beginning of the project, in our minds, cables was a cable. With 800 volts on it, okay, cable is becoming a system, and it needs to be considered as a system and with specific protections.
Thank you. Next question. What role do startups or smaller innovative companies play in the development of hybrid electric technologies?
Maybe I take it. They can play different roles depending on what they bring to the community. First, some of these startups have good ideas of innovative technologies, bricks that can be implemented as a smart manner to increase the efficiency of a component, an equipment, and so on. These are the early techno startups, I would say. Another benefit that we can look at is about those of the startups that inherently have developed a more agile process to go rapidly to not a product, a prototype, and go rapidly to testing, both on the ground and in flight. This is valuable also to be looked at. There are startups that are making some funny, fancy promises about concepts of aircraft that may revolutionize the future of aviation, to be looked at as long as this is in line with the physics, because also like real life, the physics doesn't lie. So we see very different approaches among the startups. Some of them have capitalized on aircraft concepts that deserve attention, because actually that's quite smart. Others are just selling or overselling dreams with concepts that when you look at, just an example. I told you that the very first pillar of our decarbonization roadmap is ultra-efficient aircraft. This means that we want to be as frugal as possible, to consume as low energy and power as possible. Some of the concepts that we can see on the marketplace, pushed by some startups, have a payload of 4 to 6 passengers for a range that does not exceed 200 kilometers or 300 maximum. For this, look at the installed power to lift it and make the mission up to 3 megawatt or 4,000 shaft horsepower, if I take a comparison with something that is more familiar to some of you. This is to perform a mission that is much below the standards of the Squirrel helicopter, of Airbus helicopter, that goes up to 7 packs for 300, 400 kilometers, with how much? Not 4,000 shaft horsepower on board, but 700 to 800 shaft horsepower. So I'm quite uncomfortable when people come to me and say, well, look, my concept is brilliant. I'll tell them, you need 5 times as much as energy as for a more conventional platform. So there is something that does not fit with the strategy to reduce the fuel consumption anyway. So we have to look out of what deserves attention in some of the startups that are really interesting, either in terms of products, innovative technologies in products, or innovative way of developing prototypes, and others that are probably not so realistic in terms of, are also promising for the future of aviation.
I think Jean-Baptiste wanted to add something.
Just to complement, I think here really startups and innovation is at stake. And you were speaking about the fourth generation. We have so many startups and so many companies being created now because we are at a new generation. So ideas are popping up, technology is here. There are really things which are really fantastic to be done. Startup is a really good platform to make this happen because they are exploring as well. What is interesting is, as mentioned by Eric and guests with there, as we are airframer or engine makers or big companies, we have let's say, a legacy behind us that help us to judge and to assess what could this kind of exploration and technology bring. So it's really a unique opportunity and a good balance between pushing and exploring the boundaries, as well as taking it on board of what could be a good aircraft and good business for the aviation.
Thank you. Next question. What are the flight phases you conducted with distributed propulsion only, without the TBM's main engine?
I'll take it. As a matter of fact, most of the hours of flight, electric flight, has been done with the main TBM motor in transparent. So it's not shut off, it's transparent, it's thrust equals 0, and that's to be able to measure the exact effect of the propulsion and distributed propulsion. So we have explored from stalling speed, because several stalls have been performed in each configuration of the aircraft, takeoff, cruise, and landing configuration, flap configuration, up to, I'd say, 130 or 140 knots, which is the maximum speed you can get with the electrical power which is installed. So we have covered all that without the main engine.
What is the expected timeline for the commercial deployment of hybrid electric aircrafts?
I take it. Yeah, first of all, when I see the question, I'm just reminding something. EcoPulse is a product. EcoPulse is a technological demonstrator. So when you read the question, we need to be sure that people don't think that this is a product. It's a demo. It's a demo. That's very important. So this will not decarbonize the world. It gives us the key and the tools in order to go in the right direction. So a lot of things which are in EcoPulse today will be used in short term, but maybe not the things that are most visible. Maybe things that people will not recognize from EcoPulse. Like I said, the way to demonstrate safety, the way to make a more electrical aircraft in some details to improve the efficiency, the overall efficiency of the aircraft.
Thank you. Are there challenges related to sourcing sustainable materials for this system?
I will take it for those of the materials that are peculiar to the electrical systems. Because, well, behind sustainable materials, I don't know what's really behind. Some of the materials and raw materials are critical for electrical technologies. Especially the famous rare earth, you know. Why are they critical? First, because they are intrinsic to magnetic properties that you need in some kind of these electrical designs, like permanent magnet and so on. You need these rare earth at very small quantities inside a magnet. And why is it critical? It's because it's not available everywhere on the planet, but concentrated in some areas where we may face sourcing restrictions for economic reasons and also geopolitical tensions. So for this reason, we are first trying to secure the supply of this kind of material by opening alternative sources, partnering with other than the major players that are located in only some countries today. And second, by trying to find, in some cases, alternatives to the state-of-the-art of the technology that requires this rare earth. It's not an easy thing. It's not a done deal. And third, by considering circular economy. We are not enough considering this inside our aviation industry. There is a potential to recycle some materials at the end of life, and especially these kind of critical materials. They have a chance if we take care of this, if we capture the hardware at the end of life and recycle the very valuable critical raw materials that are inside, to have a circular economy at our hands instead of having to supply additional quantities of them.
Yes, and I take the ball after you, Eric. In our tech center in Nantes, called Shaping, we are working a lot on thermoplastic composites. They present at least two key advantages. The first one, this is recyclable, so we can reuse it in order to propose new parts, and we can weld them. And so you mentioned that the physics does not lie and that the weight of the parts is key. By using also this technology, we can have better efficient aircraft in the future. So we are also working on this kind of materials in order to prepare more sustainable aviation.
Thank you. Do we have any other questions? I think, yeah, they're pending. Okay, next one. Batteries have problems on cars for the moment. What safety measures are you taking for aircrafts?
So we mentioned it just before. I mean, we know that batteries is one of the key enabler and things we need to understand to integrate them on the aircraft. And the safety is one of the main reasons, but not the only one, but to see how we manage this safety. And clearly, there are several measures that you need to do. When you start from the cells level, so the very elementary part of the battery, up to the moment you build up the complete battery module and the way you manage the system. So there are a series of things that you can implement: physical segregation, distances between equipment, material that you use, the way you design the battery itself physically, but also the system, the brain. The brain of the battery is maybe one of the most efficient way to manage the safety. The cleverer your brain you have, the more you can assess the behavior of your battery and really take the appropriate measure. And you were speaking about the Zen button in the aircraft. In fact, we want to have a brain inside the battery that is managing it. And I have to say that when you compare what is done in cars compared to what is done in industry, we are in different worlds. In the safety for aircraft and aviation is the key, the most important things. So you cannot imagine the level of effort that has been done inside the industry to increase the safety standard, and the battery is really one of the key areas we are focusing on at this time of period for developing the technology, maturing it to have it both safe and sustainable.
Thank you. We have a question from someone who actually gave his name and where he comes from. A question from Stanley, who's writing from Polytechnique Singapore. And this is a question for the three actors of this project. Can you share if there are any internship opportunities available for students?
Sure, Stanley, there is plenty of work. Come on.
On Safran side, it's quite easy. Go to the Safran website and just call for internship opportunities, and all this is made public. So we will be more than happy to welcome students that are especially motivated in joining our efforts to prepare the aviation of the future.
And I think on the Airbus side, this is really the same. We have even facilities in Singapore, but I think it makes sense to share and to see people moving across the world to bring some, let's say, cultural way of thinking and imagining the new technologies. So we have ways of doing it. The sites is there to see all the offers that are available.
And in this era of aviation bashing, we need very motivated people to work within our company in order to prepare the future of aircraft. And I think it's really, really interesting, and you have a key role to play, so we count on you.
Would you have a word to close this session to attract younger generations who indeed are facing this plane bashing?
I think Pascal said it. Today, I shared at the very beginning of this session that we had a joint agenda for the decarbonization of aviation. I'm not sure this is so much the case for many other industrial sectors. I hope so. But at least for aviation, I know we have it. Decarbonization is core and key in our strategic agenda in our companies. That's the reason why our technologists are working on a day-to-day basis. And this is a challenge. This is not a done deal. This is not an easy task. So it's quite clear for me that we need the best people to help us do it. But they have to elect what they want to do, what kind of world they want to live in the future. Our responsibility in the aviation sector as players in the value chain is to find the ways and means to make it possible to offset the carbon emission of aviation. That's what we are striving at. Okay, this is difficult. So we need people. When I am talking with young people, finding a sense to their future professional life, I tell them, should be motivating for you. At least we need you. Join us rather than looking at us and looking at what we're doing. We want you in the game and not outside the game. But at the end of the day, it's your call. It's not mine. But at least I can tell you what I'm doing, and just come.
And by joining the game, maybe they will make a bigger impact on climate change. Thank you very much, gentlemen. This is the end now of our session. We will finish with an exclusive video preview of the EcoPulse journey with new brand images from this flight campaign. Thank you for having joined us, and long live EcoPulse.